Record. Okay, we are now recording and share the screen. Right, so we're on to next section, 9.2. We're doing calculus now, the bare bones of calculus. Okay, so 9.2, 1 to 16 odd, 25 to 32 odd. Okay, I'll finish that today, and then I'll give you a quiz on 9.1, which I hope you'll find is not too difficult, especially since you get to help each other out with it. Okay, and reminder, next Tuesday is CCSF Flex Day. There's no class. So after class today, our next meeting is next Thursday. And since I intend to give you one quiz a week and we're not meeting on Tuesday, then perhaps I'm giving you another quiz next Thursday. I frankly haven't decided what I'll give you in terms of a quiz next Thursday, but I'll see. But in any event, you know, still, even if it's a surprise, you get to use your book, you get to use your notes, and you can talk about it and stuff like that. Okay, so enjoy your day off on Tuesday, March the 2nd. And after today, our next meeting is on the 4th, it looks like. Okay. All right, so without further ado, we'll go straight to 9.2. Okay, and let me check the chat. Something about attendance, okay. So yeah, if you join late, just put it in the chat. I'll get you a little bit later. Okay, 9.2, topic is continuous functions and also limits at infinity. Two topics. Continuous function is really not that difficult, okay. So there's a very formal definition of a continuous function. I'll just show it to you, but you're not actually even responsible for it. Okay, but just to let you know it exists. 9.2, page 549 in my book. This is the definition of continuity. Okay, so I'm showing it to you, but you don't even have to know it, but I'm supposed to show it to you. So I'm showing it to you. Okay, the function f is continuous at x equals c if all of the following conditions are satisfied. F of c exists, the function value exists at c. The two-sided limit exists, so the limit from the left and the limit from the right exists, and they're equal to each other. The limit as x approaches c of f of x equals f of c. Do you have to write this down? No. Should you put this on your next cheat sheet? No, you don't need to. Okay, but I'm supposed to at least show it to you. If you were to take a formal calculus course, then I might actually go over it, but not here. But the idea of being close to a point, okay, so as x is real close to c, the limit matches the function value, which basically means I can draw the point. I don't have to lift up my pencil from the paper, okay? So for continuous functions, the basic idea is that you can draw it. I think it's easier to think of drawing it without lifting up your pencil from the paper. So this is a continuous graph, smooth. I don't have to jump anywhere, okay? Now, here are situations where a function could be not continuous or discontinuous at a point, right? So here's a graph that goes like this and like this. So you have to jump up, right? So continuous, continuous, continuous. And then I got to pick up my pencil from the paper to keep going. So this function is not continuous at 2. Okay, here's another function which is not continuous at 2. There's an open circle there. There's a dot. So to draw it, it's smooth, smooth. Then you have to lift up your pencil to keep going after that, right? So that is a case where the function is not continuous. And likewise here, you go like this, and the limit exists. We would say the limit is 2, but the function value, you have to jump up to 4, which means you're not close by. You have to pick up your pencil and go to a quote unquote far away point to keep the graph going, okay? So I think the easiest way to think of continuous functions is, can you draw it without lifting up your pencil from the paper? Okay, most functions that you know of are continuous. Okay, situations where it would not be continuous would be like this, or the function is not defined. Okay, also when we have piecewise defined functions, which I'll show you. Okay, if you have a piecewise defined function, like one of these things, okay, because they break the graph up into pieces, that might be a candidate where the function would not be continuous, right? Okay, and I'll show you how that works after we look at the graph of that, right? Okay, so that's that. That handles problems like 1 through 16. Then 25 to 32, You're taking the limit as x approaches infinity or negative infinity. That means you're plugging in super big, either positive numbers or super big negative numbers. So x arrow infinity, it sort of means plug in 100, 1,000, a million, a billion, a trillion, like that. And if x approaches negative infinity, you're plugging in negative a million, negative a billion, negative a trillion, stuff like that. Now you're actually not plugging this in for most cases. You're just kind of reasoning it out. Okay, as we'll see. Okay, so let's get started with 9.2, page 556. And we had to go up to problem 32. So let me show you the problems now. Okay, so there's the graph for 1 through 1 and 2, actually. We can probably knock all of those off. And then there's 3 through 8, roughly. And 9 and 10. 11 through 16. And then let's see, 11 through 16, then 25 to 32. 25 to 32 are these. Okay, and again, anytime you see this graphing calculator icon, skip it. I'm not making you guys have a graphing calculator, so don't worry about those. Okay, all right, problems 1 and 2. All you need to do is state, is the function continuous or discontinuous? And let's make it easier on ourselves. How about continuous on the homework? You can put C, and discontinuous, you can put D, right? So you don't have to keep writing C-O-N-T-I-N-U-O-U-S and D-I-S-C-O-N-T-I-N-U-O. If you just put C and D, that's good enough. Okay. Now, before even looking at 1 and 2, of which I'm just going to read the answers, I won't write it, so you have to follow along what I say, but just kind of look at the graph, right? So continuous, continuous, not continuous at -4, right? Because you have to pick up your pencil and then keep going after that. So continuous, continuous, and then discontinuous at -2. You got to jump back up over here, and then continuous, continuous, and not continuous at x equals 0. Pick up your pencil. Continuous, discontinuous or not continuous at 1, right? Pick up the pencil. Continuous, continuous, discontinuous at, where's that? 3. Draw the dot. Continuous, continuous, discontinuous at 5. Pick up your pencil, right? And then looks like continuous the rest of the way. Okay, so anytime you have to pick up your pencil from the paper, right, to keep the graph going, the function's discontinuous. Okay, so it's pretty straightforward. All right, so we can knock 1 and 2 off completely. 1, ax is -5, that's over here. That looks continuous, right? You can draw it without lifting up your pencil from the paper. So 1a is C for continuous. How about b? X equals 1. 1, there's a hole here. So that should be a D, discontinuous. C, x equals 3. X equals 3, there's definitely a jump. So that's discontinuous. And D, x equals 0. X equals 0, you definitely have to lift up your pencil from the paper to keep going. So that's also a D, discontinuous. Okay, so the answers again for 1 in order are C, D, D, and D. Okay, and now for 2, might as well knock them all off. X equals 2, continuous, C. Be -4. -4, there's a hole there, so discontinuous, D, right? You have to lift up your pencil to keep the graph going. -2, discontinuous. You definitely have to lift up your pencil to keep the graph going there. And 5, also discontinuous. Okay, so looks like the same thing for 2. So once again, the answers to 2 in order are C, D, D, and D, right? Do you have to lift up your pencil to keep the graph going or not? Okay, so that's all. All right, so the rest of the problems, I will switch over to what I've pre-written. So again, I'll do the evens and you can do the odds later at your leisure. Okay, so it says, is the function continuous or not continuous? Okay, for functions like these, rational functions, most functions that you know of, they're defined, they're continuous wherever they're defined. Okay, so y equals x squared minus 9 divided by x plus 3. at x equals 3. Okay, now you know that the function is discontinuous at -3. If I plug in -3, I'm dividing by 0. That's a mathematical no-no. Okay, but it does look like I can plug in anything else. So at x equals 3, I can plug it in. So yes, the function's continuous. Again, for continuous and discontinuous on the homework, if you want to abbreviate C and D, that's okay by me. Okay, if we know that's what we're talking about. Okay, so that's going to be continuous. Okay, how about 6? F of x equals blah, 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 blah. They tell me x equals 4. So just plug it in and see if the function is defined or not. Okay, if I plug in 4, the denominator is going to be 4 squared plus 4 minus 20. 16 plus 4 minus 20, which is 0. Okay, you're not allowed to divide by 0 in math. Okay, so the function's not continuous or discontinuous at x equals 4. Okay, so again, over here, the function's defined when you plug in 3. Okay, rational functions, polynomial functions, almost every function that you know of is continuous wherever it's defined. Okay, so that should not be an issue. Okay, where you might have an issue is a piecewise defined function like this. So in order to tell what happens here, I'll have to do a little mini graph of that. Okay. All right, x squared plus 1, that's a parabola. Opening which way? Up. Okay, U shape. Those are continuous everywhere. Here's another parabola, U shape, continuous everywhere. But the function might be discontinuous just because I have 2 different pieces. Right? So let's do a little mini graph of the 2 pieces. So at x equals 1, I obey the top rule. Plug in 1. 1 plus 1 is 2. 1 comma 2. Plug in 0, 0 comma 1. I know it's U-shaped, so it looks like that. Okay, how about this one? Well, if I plug in 1, I will get 2 times 1 minus 1, which is 1. So I have an open circle at 1, 1, and the graph keeps going up. All right, so here's the graph. So is it continuous or discontinuous at x equals 1? Take a look. At x equals 1, there's definitely a break, right? Discontinuous. You have to pick up your pencil right here and keep the graph going from there. But everywhere else, the function is continuous, right? So continuous, 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 smooth, right? No jumps, no gaps. Then, oh, right at 1, I have to pick up my pencil to keep going after that. But after that, it looks like it's continuous again everywhere else. Okay. So you would suspect a possibility of discontinuous function if you have a piecewise defined function, that you break it up into pieces like this. Okay. All right, number 10, check the chat. All right, okay, got that. So if you just joined late, go ahead and put in the chat, I'll get it later. Okay, y equals 5x squared minus 2x. You don't need to have to make a very accurate graph, but from your earlier algebra, what's the graph of this? Well, I mean, I'm showing it to you also right there. I'm kind of giving it away. It's a parabola which opens up. U-shape. It's continuous everywhere, right? Parabolas are continuous everywhere. U-shape, no jumps, no kinks, no holes. You don't have to lift up your pencil from the paper anywhere. All right, so number 12, where is the function discontinuous? So 4x squared plus 4x plus 1 divided by x plus a half. Okay, for rational functions, polynomial divided by polynomial, functions like this, you don't ever have to worry about the top. It doesn't matter if the top is 0. You just cannot let the denominator equal 0. So I set the denominator equal to 0, x plus a half equals 0. What number makes this denominator 0? That would be negative a half, right? Subtract 1/2 on both sides. X equals negative a half. All right, so the conclusion I'm going to draw is the function is continuous everywhere except at x equals negative a half. Okay, at negative a half, you're going to get a 0 on the bottom. Can't do it. But any other number that you plug in, the function will be continuous because the function will be defined there. That's what we have here. Okay, somebody please keep yourself muted. Okay. All right. 14. And yes, the problems are generally paired for these. So when I do the even one, that almost guarantees showing you how the odd one works. Okay. So in other words, 4 is just like 3, 6 is just like 5, 14 is just like 13, and so on. Okay. So you look at the way I did the even, you do the corresponding odd. And for those of you that have the book, the odd answers are in the back of the book. Okay. Okay, how about 14? Okay, same thing. I cannot let the denominator equal 0. Okay, don't even look at the numerator. X squared plus 3 equals 0. If I try to solve it, I subtract 3. I have x squared equals -3. X squared equals -3 can't happen for real numbers, right? The denominator is never 0. Therefore, this function is continuous everywhere. I have no trouble spots for number 14. So whatever the graph looks like, which we don't care right now, okay, it'll be continuous everywhere. All right, 16 is another one of those piecewise defined functions. So at first glance, it might be a similar kind of game as problem 8. Okay, so x cubed plus 10, continuous everywhere. It's a polynomial. 2, y equals 2 is just a horizontal line. That's continuous everywhere. So the only possibility of a discontinuity is at -2. So I see what happens. What happens when I plug in -2 right here? Okay, so -2 cubed, -2 times -2 times -2 is -8. Add 10, it's 2. So it touches -2, 2. Okay, so we know how cubic functions look. Okay, they go like so. This was plus 10, but they generally increase. And then y equals 2 looks like this. Okay. Another way to think of it is you might think this should be an open circle. Okay, if you draw this first, right? Y equals 2 is a horizontal line, open circle, go like this. But then if I graph this part, that closes up the hole. So now where's there a gap? There isn't any. So this function is continuous everywhere. Okay. Or you could say from -infinity to +infinity, but that's pretty much the same thing. Okay. So the function is continuous everywhere. All right, so that is that. Now we have the problems at the end that say limit as x approaches infinity or -infinity and so on. Okay, now most of the time we're not actually going to plug in numbers. We will just rely on certain fact. I think I alluded to this last time. Okay, so I'm going to write on something that I've already written here before, just so I can save space. But hopefully you've heard of this idea. If we divide by a very big number, we get a very, excuse me, excuse me, we get a very small number, right? You shouldn't need a calculator for that. Okay, if you go 1 divided by 1,000,000, it's like 0.00000, let's see, tens, hundreds, thousand, 10,000, 100,000, 0.00001, very small. Think of it as, 1 pizza, 1,000,000 people. You're dividing it evenly. How much does everybody get? Everybody practically gets 0, right? You get a tiny crumb, right? So if you divide by a very big number, we get a very small number, okay? We'll use that fact for the problems that we have to do. All right, so again, I'll show you all the evens, and maybe I'll be willing to do some of the odds because the even ones, they seem to give more negative infinities. All right, which actually is harder than the positive infinity ones, but be that as it may. So let me show you how to do these. Okay, 26. limit x approaches infinity of x squared minus 2x. Oh, was it infinity or negative infinity? Negative infinity, sorry. It actually doesn't matter. It should be negative infinity. Okay, if I factor, okay, plug in negative 1,000,000. Negative 1,000,000 times negative 1,000,002, okay, you get a big positive. Negative times negative, positive. 4 divided by big positive, that's 0. Okay, that's 0 in the limit, we say. It's really, really small. 4 divided by a super big number, okay? You don't have 4 pizzas feed millions of people. Everyone gets nothing, right? That's the sort of the way to think about it, okay? So again, the concept is if we divide by a very big number, we get a very small number, like 1 over 1,000,000, 0.00001, right? Very small number. 28, limit x approaches negative infinity of 3x squared plus 2 divided by x squared minus 4, okay? Now, offhand, this is something that's sometimes called infinity divided by infinity, which really is no such thing. But the top gets really big, the bottom also gets really big. So what do I do in that case? Okay, there's a 3x squared plus 2 and x squared minus 4, okay? So let me show you the algebra trick that you do in a situation like this. Okay. So limit as x approaches negative infinity. The new stuff is in red. Okay. There's a 3x squared plus 2. I kind of raise it up. So if you're copying what I have, raise it up a little bit. And then x squared minus 4 gets raised up to put something. And then since both of these are x squared, the trick is to divide top and bottom by x squared like so. So in red, I've divided top and bottom by x squared. Okay. On a more accurate basis, it's 1 over x squared divided by 1 over x squared, which is 1, which means I'm not changing the value of the expression. Okay. If these were both x cubed, x cubed, x cubed, I divide by x cubed. If they were both just x, I divide by x. Okay. Now what happens if they're different? I'll show you, like this one over here. Okay, but we'll get to that later. Okay, now I actually do the division. What is 3x squared divided by x squared? 3 plus 2 over x squared, leave that alone. Okay, ignore the red temporarily. And then on the bottom, what's x squared over x squared? 1 minus 4 over x squared. Now the red. If I plug in a super big negative, negative 1,000,000, it'll be 2 divided by 1,000,000 squared. That approaches 0. Okay, so in the limit, that's 0. It's not quite 0, but it's close to 0. It's like 0.00000. It's so small, it's practically negligible. Likewise for this one, subtract almost nothing. 4 divided by x squared, that's nothing. So both of these fit the category of if you divide by a very big number, we get a very small number. In fact, maybe I should emphasize almost 0. Okay, so in the limit, we have 3 plus 0 divided by 1 minus 0, which is 3 divided by 1 or 3. So the final answer is 3. Okay. So again, the trick is divide top and bottom by x squared here. You can put a sample problem like this on your next cheat sheet, next formula sheet if you wish. Okay, the problem's finished, but I'll dig a little bit deeper for those of you who want to kind of get a feel of what's happening here. Okay, we're talking about the mathematics of super big numbers. If I plug in super big, actually notice it's x squared, x squared. So it doesn't matter if I plug in a super big positive or negative, you're squaring it, so it's positive. For super big x values, the 2 and the minus 4 drop into insignificance. It's almost like they're not there, right? They are so puny compared to a billion or something that you essentially think of it as 3x squared divided by x squared. And what's 3x squared divided by x squared? 3, which was the answer. Okay, somebody has $3 billion. No, that's not me. And I don't know if any of you have it too. Maybe if you have $1 billion, that's unusual, I guess. But if you have $3 billion, can you say, oh, plus 2? That is insignificant, right? Oh, thank you for giving me $2 more. It barely makes any dent. Okay, you have 1 billion. Oh, I got to take away $4. That's chump change to them, right? You still $1 billion, take away 4, you basically still have $1 billion, right? These are insignificant in the long run. Okay. Now, from people like you and me, if we don't have that much money, then that $2 and that minus $4, that's a big deal. Okay. But someone who has millions and billions of dollars, okay, thank you for giving me $2 more, or I lose $4 more. It's nothing, right? It's insignificant. So that's the basic idea behind that. Okay. 30 works pretty much the same concept. Okay, limit is x opposed to infinity, or 4x squared plus 5x divided by x squared minus 4x. Okay, so if you want a quick idea of the answer, and by the way, you should not just do the intuitive version on the homework, quiz, or test, right? You should work it out like I'm about to show you. But the intuitive view is for super big X, which is bigger, x squared or x? X squared's much bigger. Like a billion is pretty big, but a billion is really small compared to a billion squared. A billion squared is a billion times a billion. In fact, it's a billion times bigger, right? It's really huge. So when I look at this expression, right, for super big X, again, I basically cover these up. They are insignificant compared to these two, right? It's like they lag behind. They lag behind. It's 4x squared divided by x squared. What's 4x squared divided by x squared? 4. I think the answer should be 4. Okay. Now that's just a mental quickie way of thinking what the limit is, but you should not just do that. What you want to show me on a quiz, homework, or test is the same trick. Okay, so x squared, divide top and bottom by x squared. Limit is x opposed to infinity of 4x squared plus 5x over x squared minus 4x divided by x squared. Okay, and then I divide. So what's that divided by that? 4. 4x squared divided by x squared. What's 5x divided by x squared? Well, one of the x's cancel out. You have 5 over x. Then on the bottom, x squared over x squared, 1. Minus 4x divided by x squared. One of these x's cancel one of these x's. I have negative 4 over x. If you can't read that, that's negative 4 over x. And let me raise it up again. Okay. And same thing. When x goes to infinity, you plug in 100, 1,000, 1,000,000, 1,000,000,000, 1,000,000,000,000. You don't need your calculator for that. You know this approaches 0. It is so small. 5 divided by trillion, it's essentially 0. Negative 4 divided by a trillion, 0. So the answer is 4 plus 0 divided by 1 minus 0, which is 4 over 1, which is 4. And that's what we expected. When I just did my quickie observation, say, okay, it's essentially 4x squared divided by x squared, which is 4. Okay, but this is the proof that you want to show me for that. Okay. All right, then 32, limit x approaches to negative infinity. This time, the exponents are not the same. This one's x cubed, this one's x squared. And your problem 31 more than likely works in a similar fashion. Yeah, see how it goes 3x squared and 6x? So what do I do if they're different? Okay, so what did I do here? I divided by x squared. Okay, so bottom line, divide by whatever you see in the denominator. So 4x squared, divide top and bottom by x squared. Okay, in all honesty, if you divide by x cubed, it would also work, but it's a little bit cleaner if you divide by x squared. Okay, so for your problem number 31, I'll go ahead and just tell you. 31, 3x squared plus 5x over 6x plus 1. So the bottom is just x. So divide top and bottom by x. So if you want to jot that down in your notes for 31, divide top and bottom by x. And let's see, 27 and 29, they're both x cubed. So yeah, divide top and bottom by x cubed for 27 and 29. Okay, so if we want to just jot that down in your notes, and you can watch the video later, I've got it. But 27 and 29, the hint is divide top and bottom by x cubed. 31, divide top and bottom by x. And I can do 25, get 25 out of the way. That one gives you the answer right away. Okay, x approaches infinity. It's 3 divided by a big number. So the answer to 25 is automatically 0, right? You plug in a billion, 3 divided by 1,000,000,001. That's 0. Right. All right, so 32, I'll be done in a few minutes, folks. It's only 5:15. So if you want to ask me questions, you may. If not, then we'll just go straight to our quiz, and then that's it. Okay. All right, so divide top and bottom by x squared. Limit x approaches negative infinity. 5x cubed minus 8 divided by x squared over 4x squared plus 5x over x squared. Okay. So divide. What's 5x cubed divided by x squared? 5x. Minus 8 over x squared is just negative 8 over x squared. And now 4x squared over x squared is 4. 5x divided by x squared, that x cancels that x, so I have 5 over x. Okay, and now here we go. When x is a super big negative, negative 1,000,000,000, this approaches 0. This approaches 0. So it's basically 5x over 4. That limit is negative infinity. Okay, if I plug in a negative big number multiplied by 5 over 4, it's a negative big number. So the answer is negative infinity in this particular case. Okay. All right, I think I've done everything I was supposed to do on schedule. Okay, so yeah, we're not meeting again for a whole week. So if I give you a quiz next Thursday also, well, it should be just from this section, 9.2. So I haven't decided what I'll do yet, but it may be something to do with continuity, and you might have to do one of these limit kind of problems. Okay, but frankly, you say, do I have to study for it? I don't think you have to. You know, the quizzes, you have to admit, they're fairly low pressure, open book, open note, open discussion. So it'll probably be, you know, I'll make you answer something about this or give you one of these limit problems. Okay. All right, so I'm done. If you want to ask a question, you may. Otherwise, we'll go straight to the quiz. Again, tentatively for the calendar, everything's moved up a day, right? So I just finished 9/2. Tuesday's flex day, no class, no any City College classes. And now everything's up, so 9/3, 4, 5, 6, 7. Tentatively, the next exam is Thursday, March 25th, which is just before the spring break. So that's a nice time to have it, assuming I can keep the schedule as shown here. Okay. All right, so I'm done otherwise, folks. So any questions, you can either unmute yourself or put it in the chat. If not, we'll go to the quiz and then we're done, and have a good weekend. Okay, so anybody have a question, please? Okay, I don't see or hear anything. So let's go straight to the quiz. All right, so get your cell phones out or be ready to do a screenshot. All right, so here we go. Find the limits. Number 1, limit as x approaches 2 of x squared minus 5. That one is really easy. It's basically just algebra 1. Okay. Number 2, limit as x approaches 3 of x squared minus 9 divided by x minus 3. And I do give you the hint. By the way, I'm not necessarily going to give you a hint on exams, but you cannot substitute right away. Can you see why? If you plug in right away, you're going to divide by 0. So the hint for number 2 is to do some algebra first. Okay, after you do the algebra, then you'll be able to plug in. Okay, it's not going to take that long to do this quiz, but you have to wait until I set your breakout groups and so on, and then hopefully you can be done after that, and then we're finished. Okay, I'll hold it for another maybe 15 seconds. Everybody have it? So number 1, limit x approaches 2 of x squared minus 5. Number 2, limit as x approaches 3 of x squared minus 9 divided by x minus 3. Okay, so go ahead and get started. Once I set your breakout rooms, immediately put the names, first and last name of everybody else in your group, and then make sure they all have the correct answer, and then you can go. All right, I'll assume that everybody has it now. I'll stop the share. I'm also going to stop recording